particle of mass 2 kilograms on a smooth horizontal plane is acted upon by 3 forces in the horizontal plane. F1 has a magnitude of 8 newtons and acts in the north-south-east direction. So at this point, pause the video, see if you can draw the diagram for yourself. So first one, F1 has a magnitude of 8 newtons and it acts, here's my north axis, 35 degrees to the east. So in here is 35 degrees and that is 8 newtons, force 1. Okay, the next one has a magnitude of 6 newtons and acts in the direction of south, 20 degrees east. And that is 6 newtons, F2. Okay, F3 has a magnitude of 7 newtons and acts south 50 degrees to the west. Now, I can do all of these bearings because whatever this is first tells you the axis that you start at, and then this is the direction that you go for this many degrees. Okay, if I is a unit vector of magnitude 1 newton acting east and j is a unit vector of 1 newton acting north, now that's just telling you which direction is going to be positive for this one. So this is positive, that's positive. If they wanted it to be the other way, they would tell you that it was, negative. Determine the magnitude of the acceleration of the particle. So in this one, we know there's going to be acceleration. So your force is going to be equal to your mass times your acceleration. Now, in order to work out what our force is, we need to work out our resultant force, which means I need to resolve these three and then group their components. So that is going to be the component of this one. That's the component of that one. That's going to be a component of that one. Now, it looks like they're all the same, but we know they're not. Okay, and then acting in the J direction, we've got that one, we've got that one, and we've got that one. Now, this is just like a little trick of what angle goes where, really. I'm going to label in my right angles to make my life a little easier here. And if you draw your diagram nicer, it'll make it clearer. Okay, so let's go. Force 1. That's my angle there. If that's 35 degrees, then the angle that makes up in here is 90 minus 35, which is going to make this 55 degrees. Okay, so F1 is going to be equal to, now it's going to be traveling in the I direction. It is positive in that direction. It's got an 8 Newton force, and that is going to be cos because it's adjacent. So cos 55 degrees, close bracket. Next one we're going to put in is our sine. Now the sine is going up, so it's going to be positive. 8 sine 55 degrees. Okay, let's do F2. F2 equals, now this is my F2 force. It's also traveling in the positive direction. It's got 6 Newton force, and this direction for that one, now the 20 degrees is from here to here, meaning that that's going to be our sine. Sine 20 degrees plus, now, oh, sorry, this one's going down. That was up, this is down, so this is going to be minus 6 cos 20 degrees. F3. Now this one is going in the negative direction, so it's negative 7. This from here to here is 50, so that makes this down here sine because it's the opposite side. That means that I'm going to use the other ratio in the other direction, and it is also going down, so minus 7 cos 50 degrees. Now I'm just going to chuck a lot of this in the calculator so that I can work out my resultant force. So first one that I chuck in the calculator, I may as well just add them all from this point. So I'm going to be doing this first to get my R force, my resultant force, and then that's going to become this force that we use over here. So I'm going to put this in the calculator. Delete. 8 cos 55 plus 6 sine 20 minus 7 sine 50. Okay, and that's going to give me 7.49. Now, if you're not getting that answer, you should be checking that your calculator is in degrees, not in radians. So, of course, my calculator is in radians, so I'm going to need to change that. And when I put that through correctly, that is not that one. That is going to be 1.28 Newton force in the I direction. And my J1, now when I punch all of that into the calculator, I'm going to get negative 3.584 in the J direction. Okay, so this is the vector that I've got. Now, it tells us in the question that it's got a mass of 2 kilograms. And we are trying to find the magnitude of the acceleration. So we don't actually need to throw it into this thing at the moment, not yet anyway. We're going to be first, nope, sorry, we do throw it in. Okay, so 1.28 I minus 3.584 J is equal to 2 times the acceleration. I'm going to take this over and divide both terms by 2, and that gives me an expression for the acceleration in terms of I and J. So 0.639 I minus 1.792 J. Okay, so now I've got these values. If I want to find the magnitude of the acceleration, that just means I'm going to square both of them, add them together, and take the square root. Now I'm just going to write plus because you know that when you square the negative, it's going to turn it into a positive anyway. And that's going to give you that the magnitude of the acceleration is 1.90. So that's meters per second squared.